Hello, welcome to this video on graphing a function and its inverse. In this video, we are going to take a look at linear functions, and we are going to graph some and then graph its inverse. This lesson is kind of very straightforward, and it's going to be split into three parts. We're going to look at quadratic second and then cubics third. All right, so without any further ado, the concept for this lesson is going back to an inverse. So how do you find an inverse? Well, you're going to switch x and you're going to switch y. So when you're graphing, it's a good idea for inverses to plot the line y equals x. And you'll see it here in a dashed line. And this point, or this line, is significant for the fact that if any of the points intersect, it's going to occur on this line. So for the first example over here, we have ordered pairs. You can see them in black, and then ordered pairs, which is the inverse, in blue. And then we have one point here, which is -2, -2. Well, if I switch those x's and y's, they intersect and they touch on each other. Okay, so again, any point that intersects is going to occur on that line. Now here, example 1, example 2. On example 2, I have a linear line, and you'll see with its inverse, when I switch the x and the y values, they intersect on that line, y equals x. Okay, so here are the steps that we're going to follow in order to graph a inverse. Step 1 is to always plot that line y equals x. So we'll always do that first. Step 2, once we've actually plotted our point, we'll find at least 3 points. Okay, 3 points, and then we'll switch those. We'll switch the x and the y coordinates of those points. We'll draw a line through it, and then make sure that it intersects with the line y equals x. And then last, we will label. Okay, so very important here. Step 1, y equals x. Step 2, at least 3 points. Okay. Step 3, we will interchange them, switch them. Step 4, okay, draw your line or your curve. And then step 5, label. All right, so here is our first example, and we're asked to graph the function f of x equals 1/2 x plus 3 and the inverse. So what I'm going to do first, and I'm going to try my best since I don't have a straight line tool, but we're going to draw this line y equals x. So straight line, okay, and it's got to be dashed. Okay. So now what I want to do is I want to go ahead and plot f of x. So again, f of x, this is a linear line, 1/2 x plus 3. And how do I plot a linear line? Well, you have a b value, y equals mx plus b. Okay, you have a b value, and in this case, your b value is 3. So I can go up, I can plot my point at 3, and then you have a slope. And here our slope is 1/2. So I'm going to rise 1, run 2, up 1, over 2. Okay, and I can keep doing that until I kind of touch my line. And then I want to draw a straight line through this point. Okay, so here is my line. Now, I want to go ahead, I'm going to choose 3 points. Okay, so this is step 2. So step 2, I'm going to choose 3 points. So here's x and f of x. Okay, so I'm going to choose, an intercept is always a good point to choose. I'll choose this point close to it, and then the point on the line y equals x. Okay, so these points are 0, 3, 4, 5, okay, and 6, 6. Now what I want to do with those points is I want to take them and I'm just going to switch them. That's how I find the inverse, f inverse of x. So 3, 0, 5, 4, 6, 6. Okay, so what we get is a straight line that looks something like this. Okay, and you guys can use like a straight edge, a ruler, or an ID card that will help you kind of line out that straight line. Okay, so those are your two graphs. And notice, so step 4, does it intersect on the line y equals x? And it sure does. Okay, so we're in business, and all we want to do is just make sure this function is labeled. So here is f of x. Here is f inverse of x. Okay. All right, here is example 2. We're going to go ahead and do the same thing. So I'll graph my dashed line, y equals x. Okay, and I want to go ahead and plot my points. So h of x is negative 3x minus 1. So I know my b value is negative 1. I have a slope of negative 3m equals negative 3. Okay, so I'm going to go down 1, 2, 3, and to the right 1. Okay, and I'm also going to go up 1, 2, 3, and then to the left 1. Okay, I'm going to do one more point just to kind of help line me out so I can see my line. 2, 3. Okay, so it looks something like this. Okay, and this is h of x. All right, so I want the 3 points, and I'll just choose these points here. Okay, so I help make a table that kind of helps organize information for me. So we have negative 1, positive 2, 0, negative 1, and 1, negative 4. Okay, now I'll plot the other line, h inverse of x. Okay, and I just switch them. So 2, negative 1, negative 1, 0, and negative 4, 1. And we go ahead and plot them. Okay, so over 2, down 1, negative 1, 0, and negative 4, 1. Okay, and there is our straight line. So it's going to be hard for me to draw. Okay, so something like this. Okay, and this is h inverse of x. Okay, step 4, do they intersect on the line y equals x? Well, they intersect right here, which happens to be on the line y equals x. Hey, that makes sense. Okay, so there you have it. Those are 2 examples of graphing linear functions and then their inverse. Just switch x and y. Super, super simple. All right, I have a practice problem here for you. So please go ahead. I want you to pause the video and try this example and graph it. Okay, so hopefully you pause the video. Here is the solution. Okay, make sure you actually labeled the functions too. Do you have g of x and g inverse of x? Do we have to label? Yes, yes, you do. Okay, and then here is, oh, just one example. I thought I had 2. Nope, that's it. All right, so that is it for this video, part A. I'm going to go ahead and have a second part and a third part, which will split up quadratics and then also cubics. All right, catch you next time.